In this video, I'm going to model working out a two-step stoichiometry problem, and what that means is that at some point in the problem you're going to have moles of one chemical and grams of a different chemical, and you're going to have to use molar mass as a conversion factor somewhere in there. We're going to use the same balanced equation that I used in the previous video on one-step stoichiometry, but this time it's a little bit different. It's asking how many grams of H2O are going to be produced if you start out with those 5.0 moles of HCl. So the first thing I need to do is write my setup. I have X grams of H2O is what I'm trying to find is equal to 5.0 moles of HCl. So in this case, it's a little bit more complicated. Let's get out the map of mole land and see where are we going, where are we coming from. I'm trying to get grams of H2O. I have moles of HCl. This is kind of my starting chemical, so I'm starting here. This is my HCl side that I'm starting with. This is my H2O side where I'm trying to get. I'm gonna have to cross that bridge, but what I have to decide is where am I actually starting? They gave me 5.0 moles of HCl. That means my 5.0 moles of HCl are right here, moles of this chemical. I'm trying to get to grams of that other different chemical. That's going to be down here, grams on the that chemical side. And to get there, I have to do step 1, mole ratio bridge. Step 2, molar mass of H2O. So I'm not ever going to need the molar mass of hydrochloric acid. The first thing I need is the mole ratio from the balanced equation. Well, here's my balanced equation. I don't care about this. They didn't say anything in the problem about calcium hydroxide. I care about this. I don't care about this. And I care about this. So the mole ratio I'm going to need is 2 moles of HCl over 2 moles of H2O. Or I can use the reciprocal, which is 2 moles of H2O over 2 moles of HCl. So draw the train tracks. I'm not sure I left myself enough room in this problem. And then I look at the two possible mole ratios. If I use this one, I could cancel out moles, but not the chemical. And remember in stoichiometry, that chemical is part of the unit. Treat that like one big thing. This is the version I want to use. I want to put 2 moles of HCl in the denominator and 2 moles of H2O in the numerator. And I'm just going to buy myself some more room here. That got me across the mole ratio bridge. If I stopped and canceled things at this point, I cancel these, and I'm left with moles of H2O. That means on the map, I am here on the moles on the H2O side. Not done. They want me to get here, so now I need molar mass. Remember, that's the one from the periodic table. So we have to look up 2 times hydrogen, which is 1.008 grams, 1 times oxygen, which is 16.0 grams. It's going to end up being 18.016. I'm going to estimate. If I'm wrong, I apologize. And that's grams. But remember, it's molar mass, so it's grams over 1 mole. And because we're in the stoichiometry unit, it's no longer acceptable just to say 1 mole. When I plug this in here, I know I want the mole to go down here, but I have to write it as 1 mole H2O is 18.016 grams of H2O. And then I can look and see that moles of H2O are canceled. What I have left for units are exactly what I had here in the setup, grams of H2O. I'm ready to pick up a calculator. If you're super awesome at math, you've noticed that you have some 2's here you can cancel, but I'm not going to do that. I'm going to go ahead and plug everything in. I'm going to put 5.0 times 2 times 18.016. I'm going to come back and do divided by 2 divided by 1, and I get 90.08 grams of H2O. We have to go back and check for significant figures. We can only have two significant figures. Oh goodness, we have to put this in scientific notation. It's going to be 9.0 times 10 to the 1 grams of H2O.